So in this video, we're just going to briefly review function composition in case you've forgotten about it. We're going to need to take derivatives of composed functions. So if you think about what we've done so far, we have looked at all of the different ways that we can take derivatives when we are involving function algebra. So when you took a pre-calculus class, you would have been introduced to function algebra. And then immediately after function algebra in a pre-calculus course, you get introduced to function composition. And so now that we've developed the tools to take derivatives of functions involving function algebra, we now need to put a tool in our pocket to deal with function composition. And what we want to remember is this symbol, the open circle, is the symbol for function composition. So you read this as f composed with g, and the function that comes second in order is the function that's being input into the other function. So if I say f composed with g, I'm really saying take the function g and put it as input into the function f. So we can write it as f of g or f of g of x if we don't want to drop that function notation. And when we did function composition in pre-calculus, an important consideration that came up was the domain of the composed function. So when we have function composition of two or more functions, the domain of the resulting function is always going to be the intersection of the domains. And this is an important consideration because when we're taking derivatives, we need to know the intervals over which the derivatives can actually be taken. So here I have three examples of function composition. So the first example is the sine of x squared. So this is really the outer function f of x equaling sine of x, and the inner function is g of x equals x squared. And the domain of the sine function is negative infinity to infinity, and the domain of x squared is negative infinity to infinity. So clearly the intersection of those two intervals will just be the interval from negative infinity to infinity. Here I have the square root as the outer function. So the outer function f of x is the square root of x, and the inner function g of x is a to the x. The square root function, the domain is x has to be greater than or equal to 0, or the half open interval from 0 to infinity. And a to the x, the domain of a to the x is negative infinity to infinity. So the composed function, when you put the two of them together, the intersection between those two intervals will be this half open interval. And the last little quick example is the tangent squared of x. So the squaring function is actually the outer function. So the outer function is f of x equals x squared, and g of x equals tangent of x is the inner function. So the tangent is being fed into x squared. And x squared can take inputs from negative infinity to infinity, but the tangent of x, anytime the cosine function is equal to 0, and that's going to be at pi over 2 plus pi k, where k is any integer, you get division by 0 with the tangent function, so x can't be pi over 2 plus pi k. So the composed function is going to have this restriction on its domain as well.